I'm Miss Fung. Let's determine some rules. Here we have 4 graphs that we've been studying. Let's see if you can match the rules to the graphs. Pause the video and unpause to check the answers. So here we have a truncus, where it doesn't matter what x values they are, it's always positive, the y values. So x must have been squared. So it's this equation over here. Over here, it looks like we had a sideways parabola. So what we did was we square rooted x, so it's this equation over here. Here we have the circle, which is that ginormous equation over there. And lastly, we have a square hyperbola, which is that equation over there. The square hyperbola and the truncus are very similar, but remember when you're squaring the x value, it becomes all positive or above the x-axis. So that's the truncus and that's the square hyperbola. Let's do the next example. Here we have a graph. Let's see if you can find the equation. So the center is at 1, -2. And there's a point as well. We know the standard equation for circle looks like that. And 1 is our h and -2 is our k. So we can write our center out and we can figure out the radius after. So 1 is our h, -2 is our k. Negative, negative is a positive. Now to find the last pronumeral, we just plug in the other value, just like you did in linear. To find c, you plug in a value. In quadratics, to find the other values, you plug in a value. So we always do the same thing. So plugging in x is 1 and y is 3. So we have 1 minus 1 is 0, and then 3 plus 2 squared is 5. 5 squared is 25. So r squared is 25, or in other words, r is 5. Now r cannot be -5 because it's a radius. So our equation reads x minus 1 squared plus y plus 2 squared equals 5 squared. Last example, find the rule of this graph over here. Here we have a square hyperbola, so we know our equation should look like that. That's why it's important for you to memorize all the equations. We notice that this graph has moved to the right by 2, so h is 2, and it has moved up by 3, or k is 3. Now, we can write down the information that we know, and we notice that we're missing the value of a. To find a, we just substitute a value in. It's very similar to linear when you had to find c, or parabolas when you had to find the dilation factor. Substitute a value in and find out what the last pronumeral is equal to. Let's do that. So plugging x equals 3, y equals 4. We obtain that. 3 minus 2 is just 1. A over 1 is just a. And then cancelling out 3 on both sides, we have a equals to 1. So our equation reads y equals 1 over x minus 2 plus 3. Example 4. A graph which has rule y equals a square root of x minus h passes through the points 6, 8 and 3, 4. Find the values of a and h. So we have the equation. We will sub in the first coordinate 6 and 8. So we have 8 equals a square root of 6 minus h. We'll call this equation 1. Then we can sub in the second coordinate and we'll call that equation 2. To simplify this, we can divide one by the other. So dividing one by the other, we obtain, we can cancel out a. Then the 8 and the 4's simplify to 2. So now we have, bring the square root of 3 minus h over, we have 2 square root of 3 minus h equals square root of 6 minus h. Now square both sides, we have 4, 3 minus h, and 6 minus h on the other side. Expand, 12 minus 4h equals 6 minus h. Bring the h's to the right side since it's positive on that side, and bring the 6 to the left. So now we have 6 equals 3h, or in other words, h equals 2. Don't forget to find a, so sub it in into, let's do equation 2, so that we get 1 under the square root. So 3 minus 2 is 1, so a is equal to 4. Now that we have a and h, y equals 2, 4 square root of x minus 2. Thanks for watching. Revise all the formulas, make sure you memorize them, and have a look at the pattern in solving them as well. And I'll see you next time. Bye!